after this your answers. So I think okay, thank you for recording. I almost forgot about that. Okay, all right, we continue our class. I will share the PowerPoint. Okay, I just need to okay, someone still need to request to the class. Okay. Okay, let me. So I just want to revise back what we have learned last week. Last week we looked at how machine works. So we look at how CPU, memory, why Shafiqah need to control?
Tekan video.
Oh, okay. We look at how the machine works in details. Okay, well done, everyone, because I can see that you have created your videos. I will look one by one after this, but I show you this is one of the examples of the video that I quite like it, how the group present their ideas. Can you see this?
Yes.
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 Yes, doctor, we can see.
Can I see the one in this group? Can you on your videos open your camera? So this one just I like it because they make the video interaction. Okay, that is questions, answers. So it is like a discussion. So I will look also other videos. And this is one of the videos that I think the elements is there. There is interactions there, and they are trying to explain the details. Okay, good. Okay, well done. So don't worry, others I will also look and I will pick top 3 or top 5. Okay. Okay. How the machine works? We try to remember again. The instruction in the main memory are fetched into CPU. Okay, this is CPU, and then it will be decoded and executed. Okay, remember? You still remember fetch, decode, execute cycle? You still remember that?
Yes.
Yes.
Okay. I hope you still remember the fetch, decode, execute cycle. So my question is, how the CPU knows which instruction should be executed? Okay. So the address is the location of the instruction that is currently executed. What address? So the address inside the PC counter. So the CPU knows which instruction instruction should be executed, it is based on the address held by the PC. If you still remember, PC counter hold the address. So the address is the location of the instruction that is currently being executed. So if you want to know what is the instruction that is being executed, it is based on this address. So how to get to the location? Okay, so to get to the location, address bus, okay, address bus will get the address from the memory address register that loaded from the PC. Okay, I need my pen. Okay, sorry for that. Enter option. Okay, so at the location, so when you get the bus address, okay, this is your bus address, and then the address is 0000. So at the location, the values which is the instruction, this value which is the instruction is fetched and transferred to CPU by using data bus. Okay, I just reverse back what we have learned so far, okay, from our previous class. So at what happened at the CPU? So at the CPU, the instruction, this instruction is located first on the MBR. So this is MBR, then to CIR. Okay. So at the moment, the address in the PC will be added 1. So PC counter, we get +1 here. Okay. So that, why we add 1? So that the next address here will be fetched in sequence. So that's why the addition of 1 here. Okay. Then what happened? After just now, we have loaded the instruction here into the current register, current instruction register. Okay. After loading the instruction in the CIR, what happened next? Okay, so
Digo.
okay, so in here, there is a question. After loading the instruction in the current CIR for the fetch phase, pick one, A or B. A, the CPU need to figure out what to do. So the control unit is going to decode the instruction. Or B, the instruction will be executed by the system.
Is A.
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 Is it
A,
A?
Lemio.
Okay. I want to test whether it can be done or not. Okay. Okay. I just want to call one group. Yeah. Maybe we just look. I want to know the group actually, so that I will know more about you. Okay. I would like to see your submission here. Okay. Let me check the submission for lecture. Okay. Okay. I would like one member from group AVA. Can you request control? Anyone from group AVA? Ada tak ni? Or you do remember your group name? Hello?
Don't remember group
You do
name.
remember? Okay. So it didn't show here group. Okay, it's okay then. I just call Aida Nasuha. So Aida, can you get control?
Yeah, yes.
Okay. Try to click which one? A or B? I just want to test. Is it okay or not now? Is it possible?
No.
What does it mean?
I
A or
cannot.
B?
A.
Okay. Okay, thank you, Nasuha. So the answer, thank you. So the answer is A. Okay. So before the execution, the CPU need to figure out what to do. So the control unit is going to decode the instruction. Okay. The answer is A. But which part that need to be decoded? Okay, operand or opcode? So maybe I will ask other person. Would anyone, any volunteers to try? You can request control. Any volunteer? Maybe I just call names. No volunteer. Maybe Yang Chengzu. Which part that need to be decoded? Opcode or operand?
I think it's B, opcode.
Okay, you can try to click. A or B? Here.
B.
Okay, try to click that button. Okay, good. Thank you. So the answer is, B. So B is opcode. Sorry, the answer is A. A or B just now? Don't remember.
It was B.
B, opcode, right? Okay. So
B,
opcode.
Doctor.
Okay, thank you. I don't remember which one. Okay, opcode is the important part of the instructions that tell the computer what to do. Okay, so each computer acts based on the instruction that be defined in the instruction set architecture, and this the definition, we call it as instruction set architecture. Okay, so we can see that the topic here we learn today is instruction set architecture, because this actually framework or architecture that tell us what the computer can do. Okay, and in short, this is called ISA. So I like this figure. Many times I use this figure. You can see that this is a person. Is it like you? No? Okay, when you're doing programming, sometimes there are so many errors, and you don't know, you think that your computer makes wrong. Okay, so the computer only does what you tell them it to do. So what it can do, the capable of the one of the computer is based on the functions. So this function is defined in instruction set architecture. Okay. This is our topic today, which is instruction set architecture. And this is the vocabulary of the machine. So this is why we learn this, because we need to know in the fetch decode cycle is involved instructions. So you want to know in details what type of instructions being involved. Okay, so this lecture note is prepared by Dr. Dalila and also me. So in our journey, one of the important part in understanding how the machine works is ISA. Okay, so this is one of the important part in our journey. Okay, so what is ISA? If you look the definition here, in the formal definition is the specification of the instruction that the computer can perform, and also it's defined the format for each instruction. So this is ISA. So ISA is an interface between hardware and the computer and of the computer and the software or high level language. So if you can draw here this box, okay, so we can say that all these boxes are software, okay, that run on the machine. So this is the hardware. So in ISA here is the interface. So this is the interface, okay? So ISA is the interface between all the software. So this is ISA between all the software that run on that machine, okay? So because there are many types of software, some built using Java, some built using C++, some are built using C, okay? And the hardware, there are many types of hardware, Intel, i5, or before this 86. So this will be the layer, or we call it interface, between the software that run on that machine. And the combination of the hardware and the software here and the ISA, we call it as computer architecture. Computer architecture. So computer architecture consists of ISA and also the hardware part. Okay, next. So ISA contains a number of instructions from 4 different types in general. Okay, so we look what are the 4 different types after this. Okay, there are 4. Okay, what are they? 1, 2, 3, 4. We will look after this. So one of that is data processing. Data processing is one of the type. And another type is data storage. Okay, so here, what is the answer? So from this diagram, you can see that this is the instruction or the representation of the instruction, which is load, add, or end. So which instruction is belong to data processing? Anyone? What should I write here?
Add.
Okay, add, good. And the second one?
Load.
Load.
Okay, good. Low je, ngantuk ke? Okay, so these are the examples of types for ISA. Okay, and then we look at the details of the 4 types of the ISA. Okay, so these are the 4 types of the ISA. So we can see that just now we look at data storage. So what is data storage? Movement of data into or out of register or memory. Okay, it's different than data movement. Okay, can you see the difference? Because data storage is only involve the memory and also the CPU. So the functions that support this, we call it as data storage. But this one is data movement. It is from the results located in CPU or memory. These results, we're going to get the results to the users. Okay, so that is data movement. Just now, data storage, what is the example for data storage just now? Do you remember?
Load.
Very good.
Load.
It's one of the examples. Okay, then we look at data processing. Like the name is process, something that we can process. Of course, it will involve arithmetic instruction and then logic instructions. Okay, just now, what type of instruction?
Add.
Add. Okay, good. Okay, if you want to know more about this, you can find in the lecture note. Okay, this is the activity notes. The lecture note, there will be more information about this. And lastly, the control. Oh, you cannot see here, but you can see all the text in the lecture note. Okay. So basically, control is to control the sequence of the instructions, and also to control what should be happen next. Okay. So and then I proceed with this one, which is the element of instruction set. So this is the elements contains, if you look here, it has operation code. Okay. So what is operation code? We call it as opcode. Okay. Opcode specify the operation. So if talk about opcode, you refer it as operation. So OP here, opcode operation. So what the operation that need to be performed is based on the opcode. And next, we also have source operator reference. So source means that the input. Okay. What is the address from the memory that can be the input of the process? Okay, this is a source. The results is the operation may produce a result. So when the CPU produce the results, CPU, so it would like to store the results into the memory. Okay. So this is the elements of instruction set. So every instruction set must has this one, opcode, must has what is the input, what is the output location, what is the input location. And sometimes they also have this one, what is the address of the next instructions. Okay. So if you look here, okay, until now, any questions so far?
No, doctor.
Okay.
So far, okay.
Okay, can I proceed? Or you want to break? Proceed now?
And proceed.
Yes.
All right.
Proceed.
You can proceed, Doctor.
Okay, I proceed. um, so in our examples that you use in our class, we use 8 bits. Okay, 8 bits format. Okay, if you still remember the video that you create together with your group member, they are 8 bits. For example, here, for example, for load, for this instruction, 0101, and then the address. If you still remember, the address is here, 0101. So this is the 8-bit format. So the most significant 4 bits is for opcode. The least significant 4 bits is for operand or address. So here, what is it similar, right? Is it 0000? Yeah. Okay. It is same. So what is the most significant bits for the opcode for this one?
0101.
Yes, 0101. How about the address?
Same
Same,
0101,
right?
but belakangnya.
101.
Yes, same one. 0101. Okay. The second one, there is no address, right? How about the third one? 0, right? Okay, the address is 0 and the list of front is 0. Okay, so it means that if you look at this instruction, you can divide into the format. This means that 4 digit is for the operand and another 4 digit is for the address. Okay, so that is how you look the format of the instruction. Okay. Okay. So far what we learned is that the instruction that it has 4 types. Okay. If you still remember the types, and then the instruction also have the format. Okay. In order to tell the computer what to do, okay, this code need to be decoded by the control unit. So decode is done by the control unit. So control unit will do this action. Okay. The instruction for assembly language for this executable machine instruction 0101 is. So any guess?
Load.
Load.
It is load.
Load, doctor.
Okay, what is assembly language? So the symbolic instruction to represent the numerical data from which the machine language program is derived. Okay, so that is what we call as assembly language. It is the numerical data that represent that it is to represent the numerical data. Sorry. So load is to present this numerical data. Okay, so as you can see here, this is the example. Okay, what does it means? Load. So I would like to give control. So this one. Okay. To go to arrow first. Sorry for that. Not working. Okay. So I would like to give control someone in the class. Maybe the last one. Who is the last one here? Oh, okay. Shiruta Kriti. Are you here?
Yes, I'm here. It's just
Okay. Which one is the right answer?
okay. Give me a moment, Doctor.
All right. You can discuss with your group.
Yeah. Okay, thank you.
Are you group here? So you can
They are all
you can
good.
help you. You can give suggestion to her. Okay.
Yeah. We are discussing now. Madam, a
Oh.
moment.
Using WhatsApp or what is the communications tools that you use?
Communication tools. We use
What are
WhatsApp.
you using to discuss? WhatsApp.
Yeah,
Oh,
WhatsApp.
okay. Others also can think what is the right answers. Okay.
டி ஆன்சர் என்னது நீ என் குரூப்ல முட்டாளுங்களா இருக்குதுங்க சாரி
Okay. So what does it means by load? A, to load value from memory address stated in the operand to the CPU. Okay. So if I cannot draw here. Or to load value from CPU stated in the operand to the memory. So first from memory to CPU, second from CPU to memory. Which one? Yeah, you can give answer now.
Yeah. I think it's A lah, A, madam.
Okay, try first. Good. Correct. So it will not go to other slides. It will just give you claps, applause. Okay. Thank you very much.
Okay.
Yeah. Yeah.
Okay, thank you.
Okay, thank you. So I think you have a good discussion with your groups just now. So
Yeah, I had.
I hope others also can pick the right answers. So the load means here is the load value from the memory. If you still remember, we load from the memory into the memory registers, which is this registers is inside the CPU. Okay, because from CPU to okay, let me change it first. Because let me just draw memory. From memory to CPU, we call it load. The function is load. But the CPU to memory, there is another instruction to do that. That instruction is called stop. Okay? Which means that this one is stop. Okay, good. So we proceed. E, what happened after decoding? Okay. So after decoding, the CPU will execute the command. So when the CU control unit has decode, so the control unit now know what they need to do, which is to load. Okay. So after the decoding, the CPU will execute. So if you still remember this phase, fetch, cycle, decode. Before this we fetch, and then we decode, the control unit decode, and now is the time to execute. So what happened during execution? So during the execution phase, the address of MAR will be changed. Okay, so what it will be here? Any suggestion?
0101.
Okay, good.
0101.
Yes, good. 0101. Okay, because we fetch this instruction. So this instruction will go here and will be decode. So when we decode here, we would like to load the value from this address. And the address here is 0101. So this is the decode phase. So next, during the execution, this control unit will control the execution. So first, it will update the address in the memory address register to be 0101 because we would like to get data from this address. So this will go to address bus, and the address bus will go to that location, which is 010101. So at that time, the value at that address, which is 01101101, will be transferred into memory. Okay. So if you see here, this data is base 2. Base 2. Okay, my question is how to convert from this data to base 10, which is decimal. Okay, convert from binary base 2 to decimal base 10. Okay, anyone? Okay, how to convert from binary to decimal? Did you learn this? Maybe
Yes.
your matriculation,
Conversion. Conversion.
Yes.
So
Use conversion. Yeah.
online conversion. So how to do that?
Punya calculator.
Calculator.
Two
Oh,
to the power of. No.
so you use calculator in
Put.
exam? You can bring calculator, right? So you just use calculator.
Yes.
Yes.
Guna
So we
calculator.
cannot-
Yes. Yes.
You cannot put this as exam questions, right? So you remember this one?
Yes.
Yeah. Just want to revise you back. Okay. So this
Yes.
is 5, 6, 7, and 8. Okay, so what is the value here is 1, 0. Betul ke ni? Betul kan?
Betul. Lepas tu darab.
Kan?
Betul. Lepas tu
0.
darab dengan 1, ada yang darab dengan 0, lepas tu semua tambah.
Betul.
Ingat pun
Tu dia.
Boleh
Ingat.
tak, And then you get, so anyone, you have calculator there?
Internet.
Yeah, actually you can use just internet, right?
Yes.
Anyone use internet? What is the answer here?
109.
100?
109.
109.
09.
Just want to complete this one.
109.
So the answer is 109. Okay. So in the memory, you only see the machine only understand this, but actually the value here is 109. So that is the value, the exact, the real value inside the memory. Okay. So all of you get this, right? Masih ingat,
Doctor,
Yes.
I have a
Madam, I get
question.
189.
Yes. What is your question?
Yeah, just for last slide. I don't understand why the memory address register is 0101.
This one?
Yeah, the memory address register.
Oh, okay. So let me explain again. Okay. Can we clear this one? Just want to see whether we can clear or not. Okay, it's okay then. Because we now would like to execute. Okay. If you want to execute, we need to see what is the instruction that need to be executed. So the instruction here is 0101. Do you know what is the address here?
No. Because the memory get the 0000 the address and get the value.
Okay. The address here 0101. Do you know why the 0101 here?
Yeah, that's what I don't understand.
Okay. So because it is here, right?
Yeah.
Yeah. Because it is here. So this is the format for that instruction. And then we divide here. The first 4 is for opcode, and the another 4, because it is 8 bits, another 4 is for the address. Okay, so this is the instruction that now in the current instruction register. So after this control unit decode, which is already know what the computer need to do, which is to load. So the control unit tell the CPU to load the data. So what happen if you want to load the data, you need to tell the CPU what is the address to load from the memory. Okay, so the address is contained in the instruction, this one. Because the instruction is load 0101. This means that I would the instruction
I
one.
get it.
You get it already? Okay.
Yeah, I get it. Thank you, doctor.
Okay, good. Okay. Yeah, Yalen, okay? How about others?
Doctor, I have a question also.
Okay.
Since the address that the new address that we got from the control unit, we take 0101, right?
Yes.
And then
Correct.
we send it to the MAR through address bus.
Yes.
So the new address will be 0101 at the MAR, right?
Yes. Correct.
And when we do the operation at CIR, it will automatically +1 at program counter, right?
Yes. Correct.
So at the program counter will be 000001, right?
Yes.
then it will go to the MAR also.
Yes.
Then
So you, mhm.
we have two values at the MAR, which is
Ah,
0101 and 0001. Is it?
okay, okay. Yeah, yeah.
Unprocessed there.
I think I know your because both of them go to the same register, right?
Yeah.
Yeah, okay. So good
So,
questions. So
okay.
yeah, I will explain now. So
Okay.
this one we call it as per cycle. Okay. And
Okay.
then there will be another cycle, which is fetch,
Mm-hmm.
decode, and execute. So this is
Yeah.
second cycle. Okay.
Okay.
So what happened is that during this first cycle, it will
Mm.
complete first the cycle
Okay.
until the execution. Okay.
Okay.
So in this cycle, the execution is need to load data from memory to CPU, right?
Yeah.
Yeah. Okay. So you load data. Sorry. Okay. So you load data, and the data
Doctor, I
uh,
can. Okay.
is load here, right? Uh, because it is data, data will save here. That finish.
Mm.
Finish for the first cycle. This one.
Mm. The
Next,
data will, where the data will save, doctor?
the data. Okay, I have not. Okay, it is actually in the other slides.
Oh.
But it's okay. I just try to explain. The data will go to the data bus and will go
Mm.
to the memory buffer register. And
Okay.
then because it is data, it will not
Mm.
go to the CIR.
Oh.
So 109 will go here.
To the
The
accumulator.
accumulator. So
Okay.
after finish this cycle,
Mm.
the control unit will
Mm.
look into the next instruction, right?
Mm. Yeah.
At this time, you will, this one is finished. 0101 is finished, right?
Oh. So
After that one,
the new 0101 is sent to the accumulator lah.
uh, here, MAR.
Ah. First it was sent to the MAR, and
Yes.
the then you said the 0101 is finished. You mean then it is sent back to the memory buffer register
No, no,
and
no,
to
no.
the accumulator? Oh no.
I mean, this cycle is finished. These cycles only want to do to put data from memory into CPU. That's
Oh.
all.
Okay.
Yeah, that's all. Because
Okay.
we have next operation here to add
Oh,
using
which
this data.
is from the program counter, right?
Yes.
Okay.
Okay. Actually, this one is not exist. Okay.
Which one?
At this first cycle, only this one exists. And then come to the another cycle, which is the what is the second cycle is based on the program counter. Only
Okay.
at this time it will upload loaded to the MAR when the first
Oh.
cycle finish.
Okay. So
Okay.
actually the first cycle is finished when the 0101 address is sent to the MAR, right?
Uh, yes, send to MAR and then it get the data. You know,
Oh, oh,
you want to get the data, not yet get the data. So you
okay.
need to go there, go to 001. The data is just now we calculate. This is 109, right?
189.
109. So this data we bring back using database, go to this one. And this is temporary, so we need to put in AC, accumulator.
Okay.
So, okay, you get it until now?
Yeah, okay.
Okay. Okay, good. So any more questions so far? So I think we have a break now. Is it okay?
Yes, please.
Yes,
Okay.
doctor.
So we have about 10 minutes break.
Okay.
See you again.
Sorry, doctor, can you show your tendency QR code again?
QR code. Okay, okay. I will show again the QR code. Okay. So let me. Okay.
Okay, thank you, doctor.
Dah boleh dah, doktor.
Welcome. Okay ke tak? Dah okay dah? The one that have problems just now?
okay, okay. Dah boleh
Dah
share.
okey dah.
Okay, Alhamdulillah. Alright, that's good.
Saya punya tak boleh lagi, doktor. Saya punya tak boleh lagi, doktor. Doktor.
Hello, doctor.
Doktor.
Doktor
Ya?
Saya punya still tak boleh imbas lagi.
Ada error eh?
Dia
Hello,
still.
doctor. I cannot scan this code. Can I request control?
Oh, you want to request control, okay? Let me allow.
Okay, doktor, saya punya dah boleh masuk dah.
Boleh dah eh? Okay.
Hello, doctor. Hello. Hello. Hello.
Yes,
Doctor, can I request control also?
you can, okay. Right,
Okay, thank you, doctor.
okay.
Hello, doctor. Can I request control?
Yes, you can try now. Request. All right. There only one at a time, right?
Hello.
Sorry, doctor. I can't control. Can you?
Yeah, because as far I know that only 1% at the moment. It cannot allow
Okay.
multiple control. So
Okay.
you just wait your friend here finish.
Okay. Thank you.
All right. Harin, right? Harin, is it okay?
Yeah, doctor, I think the line a bit slow, so it's lagging a bit.
Oh, okay. Because I see
Sorry,
that
sorry.
you are there.
Sorry for the inconvenience. Sorry, sorry.
It's okay. I just wonder where you are. It's okay, just try.
Hello, doctor. Hello. Are you still in? Okay.
Yes, I'm here.
Yeah, I'm sorry to interrupt you that because I didn't in the class last week, so I didn't have a group. Could you detach a group for me?
Is it a group for tutorial?
Oh, yeah.
Lab?
Both of it. I don't have both of it.
Okay. So I think you are second year student, right?
Yeah.
Okay. So do you have the schedule for our class?
The schedule for our class?
Yes, you have the schedule because you can pick any slots that you are free based on your timetable. We have today class in the morning, on Wednesday, on Friday. So you can pick. Maybe you can WhatsApp me after this.
Sorry, pardon.
Do you have WhatsApp? Or you can email me?
Oh, okay. I will. Thank you.
Okay. All right.
Sorry, doctor, but done already. Thank you.
Okay, Harin Raj, right?
Okay. Yeah. Thank you, doctor.
Welcome. So, okay, last one. Last one before we. After this, I will open this QR code in the end of our class. Okay. So, sometimes lecturers also have problems to scan the code. They said that the suggestion is to change your phone, your mobile phone. I don't know whether this is the right solution or not. Okay, just we're waiting for your friend. So far, we have looked into the instruction set architecture, which is the interface between the hardware and also the software that runs on the machine. Okay, so it will define what the capability of the computer. Okay, the list of functions that can be executed by your computer. So that's why instruction set architecture is important and is one of the important part in your computer architecture. Okay, after this, we will look at what your friends asked before. Okay, maklumat terwujud. Okay, so thank you, Wang Nan. So I think, yeah.
Thank you, doctor.
Welcome. All right, so I will proceed now to our lecture. Okay, this is what your friends just now asked me.
Doctor, I have a question.
Yes.
Back to the previous slide.
This one?
No, the one that execution and decode and stuff. Okay, this one will do.
Yeah.
So during the execution, right? Based on the current instruction register, 01010101. So the first 4 bit is the opcode, right?
Yes, correct.
So 0101 means load, isn't it?
Yes, correct.
So next 4 bit 0101 is the operand, which shows the address of the value, right?
Yes, correct.
So refer to the address 0101 is 01101101, isn't it?
This one?
Yeah, yes.
Yes.
So is it gonna load this value to the accumulator?
Yes.
So how come in the chat they say it's gonna load 110111101? I get confused.
In the where? Where do you get that?
In the chat box.
Oh, sorry, I haven't checked the chat box. But don't worry. Can I proceed? Okay. Don't worry. What's your name?
Taufik.
Taufik. So Taufik, I will explain here. Is it okay if I explain first?
Okay, doctor.
Okay. Okay, so good questions because you want to know what happened next, right? During the execution. Okay, because
Yes, I want to know, and I get confused by the chat box.
Okay, I will look after that. What is the in the chat box? But at the moment, I will try to explain first here and to see to confirm what is written in the chat box. Okay.
Okay, doctor.
All right. So, the value at the address. So we would like to get those. So I just want to highlight here. This is the execution phase. Okay. So the execution phase is we would like to execute what is the instruction in the CIR. Okay. So before this, the decode phase, the control unit has defined that this one is load. So it will be load 0101. So the computer now know what to do. So next, the execution phase. What happened is that it will look into this address. And loads mean we want to load data from the memory into the CPU. Okay. So we want to load this, the value inside this address into the CPU. Okay. So this value will be transferred to MBR and then to accumulator. So what is the value here? Anyone? What is the value in the address 0101?
01101101.
01101101.
Yes. So this is the value. We calculate just now, right? The value is 109, is it correct?
I got 189, madam.
189.
How did you get 189?
I used my calculator.
Yes, calculator.
From the same value?
Yeah, from the same value.
0 and 9 or what?
Are you sure?
Yes, I'm positive.
Let me check.
Try again.
It's 109.
Okay, let me try.
Try again.
Maybe we try again here.
Okay,
I
okay,
think-
you guys are right. Yeah, my mistake.
Okay, so
It is
shortcut.
109.
Maybe you just put the wrong number just now.
I think I have an idea why a lot of us got 189 at first. I did
Because
my
you put one
calculations. No, I'll just say what I got at first lah. I got 189 by calculating the binary that is displayed, what the doctor has written. As in the slide, there's the number that she has written, and then she showed the base beneath it, power base to show us how to decode it, and then there is the actual binary down that probably she copied straight up, but maybe because I followed that, maybe the binary got swapped, so that's why a lot of people go 189.
Okay, so maybe
Probably.
I done it wrong for this, right? Maybe
No, doctor, you're not wrong. But when you write the binary above, when you copy it back up and we follow the binary, that binary might have been wrong. But then you copy pasted the value, the original value, back into the binary calculator, and that is right. But
so is
I
it correct?
I have no way of verifying whether the variable you're written down, whether the binary you're written down on the slide is the same or different, because the slide is gone now. So.
Oh, okay. So, if you calculate one by one, you cannot get 109, right? Just we look back.
That's not what she mean, doctor. She mean that you write the value wrongly. The
Okay.
value wrongly. Yeah, that's it.
So is it solved now?
Yeah, it's
Yes,
solved already.
Okay, so the value is 109?
Yeah, it's 109.
Okay. So who is just now? So sorry for that. So now all clear? Or maybe yeah, maybe the just now we need to look back, but I think I have clear the, we cannot see what I have written just now. So sorry for that. But is it clear now? The value here is
clear, Doctor.
0, 1, 0, 0, 1, or it is equal to 109? Is it clear?
Yes, it's clear, Doctor.
Yes, Doctor.
Okay, thank you. All right, so the value will be transferred to MBR and then go to accumulator. Okay, so what happened is that during the execution case, the value inside this address will go into the data bus. Okay, and then the value will be 0, 1, 1, 0, 0, 0, 1, and then it will not go to CIR because this is data. Okay, for your information, in the memory, the memory is divided into what we call instruction, and then another part we call it data. It only contain data, and if you want to know the data, like we do just now, we convert the data into decimal, so we know what is actually represented by these binary numbers. Okay, if it is instruction, so we will know that for the instruction, the first 4 will be opcode. But if data, you calculate the data as a binary numbers, base 2. So you convert into base 10, so you get this number. So during the execution, we fetch or we load the data from the memory into the CPU. So when you go to the CPU, it will go first to the memory buffer register. So every time the interaction between memory and CPU, anything will go first into memory buffer register. If it is instruction, it will go there. Else, it means that it is data, it will go to another register, and this register we call it as accumulator, OAC. So accumulator is used to store immediate arithmetic or logic results, or to store anything needed, data that needed by the CPU for the next execution, or for the maybe in the future they need that data for any function. So at this case, accumulator will get 109. Okay, are you clear? So this is
Doktor, saya ada pertanyaan. Macam mana kita nak tahu berapa banyak ada instruction dan data tersebut dalam value tu?
Berapa banyak instruction maksudnya?
Means macam yang doktor buat tu, doktor just highlight macam 3 value pertama tu dan yang seterusnya semua data. So macam mana kita nak tahu dia macam?
Oh, tak tahu. Saya tak tahu.
Tak tahu,
We
memang
don't know.
random sajalah.
We don't know. I just said that in the memory there are parts for instructions and also there are parts for data. I just illustrate like that. Okay.
So only the data will be stored in the accumulator, right, doctor?
Yeah, in the CPU.
Alright, doctor, thank you.
Okay. So after the data inside the accumulator, or we call it SC, so this is the results of the first cycle for instruction in address. If you still remember, in our program counter, the address is 0000. Okay. So what is the answer here? is used to store intermediate arithmetic or logic results? Anyone?
Accumulator.
Yes, good. So, or in short form, AC. So, accumulator is used to store intermediate arithmetic or logic results. Okay, and all of this is the result of the first cycle for our instruction just now, which is load 0101. So our cycle is finished now. So, any questions so far?
Doctor, I have another question. In the instruction, what's the difference between AND, add, and load? Because based on the video that I saw from the ED puzzle, it's quite similar, the function, based on my understanding.
Oh, the difference between load and add.
Load, add, and
Okay. So it's okay. It will be your homework. I will explain. I mean, you will discuss after this. Yeah. So but at the moment, I can tell that load is only load. It means that we just load from the memory into the CPU.
Okay.
But add, there is a arithmetic there. For example here, okay, maybe we look into the next slides. Is it okay?
Okay.
I explain that in the next slides.
Okay, doctor.
Okay. So this cycle finish. Just I see what is the next slide. Okay. So just now the cycle finish, and this is the new cycle. The question here is, what is the address for the new instruction that will be run? A or B?
A.
A, right?
A.
Good.
A.
So usually in the last one, so it will be this one. So the answer is A. Okay. Okay, maybe I explain a little bit about add. Okay. Because this one is actually we need to update this one actually. Technically it's wrong. What do you think it will be? If you refer to this.
01011101.
0101. Okay. Let me check. Is it similar? It also means to load, right?
Yeah, the opcode means to load the address.
Yeah, but its address is not here, so it might be in the. Then you can find the address. Okay. So in this case, the opcode is 01001, and then the address. So what do you want to see? What do you want? Just now, we add this number. Maybe you want to add this number with this number. Okay, you want to add this number with this number. It will, so the right value here will be, if the opcode for add is if the opcode for add is 0001, for load is, I just give examples, okay? If you look into manual, I will give you some resources about that. They might have different code for this. Okay, so if you want to add from, let's say this is A, you want to add A and B. Let's say your add A and B. So you want to add A and B. So the load here is 0101, the address. And what do you think the address here? Someone? Anyone? Are you
I
lost?
think, yeah, I'm quite lost.
Yeah, I'm quite lost. Is it at
Is it
bit
1101?
value or for bit value, Doctor?
You can guess.
Doctor,
Guess
I'm
first.
totally lost.
Oh my God. Who is not lost? Who can explain? Maybe one of you. Anyone?
Cause it's so weird to add bit value with it. It's like for bit with add bit.
What is this value? Can you count? Try to look. Calculator. What is the value? Anyone? Convert to decimal.
It's 125, Doctor.
125.
25.
Okay. So we want to add these two number. Okay. We already have in our accumulator, we already have 109. Okay. So we now want to add data from this location. So what is the address? 1001. So we know the address. So what we should do here is add. This is the opcode to add. So we put the address here 0110. Can you get that? No? Yes?
Sorry, Doctor. Is that opcode or operand?
This is operand.
Oh, operand.
The 1101 is operand, right?
This is opcode.
It's opcode. Then which is operand?
Yes?
Then the 1101 is the opcode.
This one.
At the beside the address 0110 in the binary.
This one?
Yeah.
Here? Uh-huh.
Okay.
So this is opcode.
Doctor, are you using a mouse? Because I can't quite see it.
I'm using drawing. Can you see that?
No, Doctor,
Okay, I
your
can.
drawing are a bit confusing.
Yeah, we can't quite
We
see
don't know
it.
where is the indicator.
Yes, we get confused
I
because
think
of
Doctor
that.
is using drawing tablet. That's why.
Can you see my drawing? Okay.
Yeah, I can see your
It's like
drawing.
it's like sometimes you say
YouTube.
this value, but then we don't know where is that value.
Ah,
Oh, you cannot
We can see
the
We don't know
value.
where to look.
right?
yeah.
We can't see where is your indicator going.
We cannot see your indicator.
Because you cannot see my drawing. Is it?
We can see your
No, we
drawing,
cannot
but
locate your
We can
cursor.
see your cursor.
We cannot locate your cursor. Yeah.
But if I
Like
circle
when
like
you
this,
said
can you
this,
get it? Can
like
I circle like
example,
this?
when you said this number, we don't know which number you meant.
Okay. So maybe I explain again this drawing. Is it okay?
Yeah, yeah.
I don't know how to clear the drawing. There anything that I can do?
废话，你骗人是。
老实话的啊。
Just want to clear back. How to clear? Oh, erase all in. Oh, this one. All right. So okay, okay. This summary already. Let me go back. This one. Let me clear first. Erase. Okay. Okay, can I explain again?
Yes, please repeat,
Yes.
doctor.
Okay.
Yes, doctor.
Okay, if I put my cursor like this, let me my cursor. Where is my cursor? I can't find my cursor. Okay. Okay. The value will be transferred to MBR and then accumulated. Okay, this is finished, right? Do you get this? This one is the execution phase. Execution. Okay. At this moment, all get the idea for the execution?
Not
Yes,
exactly,
doctor.
doctor.
Yes.
Yeah. Any question here? Oh, the load is okay, right? Yeah, this one. Yeah, I think the best thing is for you to do the exercise. Is it okay? Like before, when you do the video, is it increase your understanding? When you discuss together with your groups?
Yes.
Yes. It is much better.
Yes.
Yeah, because sometimes complex. When you discuss with your friends, you will gain, especially when you teach others, you will become like a teacher. If you are a teacher, try to think you are a teacher or a lecturer. So suddenly you become pandai, you know. I mean, not all of you are very clever. That's why you are in UKM. But I mean that based on my own experience, because I also did my degree in UKM. I also took a subject like this. So when someone asks me these questions, some questions which I don't know the answers, but because they asked me, and at that time I'm trying to think very hard, and suddenly I get the idea to solve the questions. So the best thing is the questions come out in the final exams, so that I can get the correct answers. So I think that's why don't worry about this. There will be exercise for you to also in a group discussion. But before that, I just do some summary first. What we have learned today. So all in all, instruction set architecture, which is ISA here, specify what the CPU are capable of doing. Okay, capable of doing. So it has a list of functions. The users might want to add numbers and display the results. Okay, you want to do some things, I want to get back the results. So what happened is that in order the user to communicate with the machines. Okay, if you are in front of the machine now, so imagine you are users and you want to communicate the hardware, which is the computer, that you want to tell the computer to do something. What the users needs to do is the users need to write a high level program. You can use Java, you can use C, or can use C++ or other high level language that you can use. So this high level language will be compiled by a compiler and it will become assembly code. Like I said before, assembly code is the representation of the binary. So this high level is translated into assembly code based on the ISA. So the function here, load, if you remember just now we use load, but there are other examples from the second video from the easy puzzle. There are also some examples of the instructions. So this is based on the instruction set architecture, the function inside the assembly language. You can see the function because it is easier for us to see in the assembly code because it's difficult as human to see the function in terms of binary code, which is 0101. Okay, so the high level language is translated into the assembly code, and then what happened? It will translate it into binary code. So from the assembly code, it will translated to the binary code by using assembler, and then this code can be understood by the computer. Okay. So as a developer, you want to know more about the instructions. You can see these are the documents that you can look further. You want to see what are the instructions inside the architecture 64-bit and also inside the architecture 32-bit. Okay, so this is for the group discussion. I think after you discuss with your friends and see the flow here from, oh, I didn't say, okay, just remind me to share the reference for this book, okay? This is also the second, this is one of the textbook used, okay? Before this, I share Essentials of Computer Organization, I think, from Linda something. And this is another one. This is from William Stalling. Remind me to share the full name of the books. So I took these figures from that book, and it explained the instruction involved to add two numbers. Okay, so as a basis for you to discuss in the group, I just explain briefly here. Maybe you don't understand, it's okay. We just maybe play again the recording here, and then you can discuss with your friends based my explanation. Is it okay? You are still with me?
Yes, Doctor.
Yes, Doctor.
Okay.
Doctor.
Okay, Doctor.
Okay.
Doctor, how
Yeah.
about the lecture slides? Do you get the lecture slides?
Yeah, I already upload in the UKM folio, both.
Okay, thank you, Doctor.
All right. Okay. What we have here in the memory also, this is very clear. Like one of your friends said, it is very clear here that part of the memory here is referred to instruction. And another part of the memory is for data. Okay, so you can see here, this is for instruction and this is for data. And what do you think? What is how many bits here? How many bits?
The memory is 4 bit, right?
4 bit.
4 bit.
Eight.
Let me check. How do you get 9?
Zero to 9. It doesn't look like 4 bit. Yeah.
This is not in binary, right? It's not in binary.
Decimal?
Maybe in decimal. Okay, yes, maybe in decimal. Let me. Okay, how to convert from 9 to binary?
Divide by
How?
2. Divide by 2 or use the 1248. 1248.
So it will be 0, 1, 0. Is it correct?
1248. 1001. I don't know.
Okay. So I will check further, but I think this might be 60 bits.
1001, doctor.
1001. 1001. Oh, correct. 1001. Right? So 1001 is for 9. Okay, good. Thank you. So I think this is 16 bits. Let me double check about that. So if you want to convert based on the binary. Okay. This is the register, PC counter, program counter, accumulator, and this is CIR, instruction set, current instruction register. First thing first, you get the first 300.
Apa?
Sorry, any questions?
Hello.
Can you hear me? Can you hear me?
Yes.
I can hear you, doctor.
Yes.
Doctor.
Okay, I will explain until step 1 and step 2, and then you try to discuss afterwards. Okay. In step 1, the PC counter show that you need to load the instructions that need to be executed now is from address 300. So what happened in the fetch phase, the instruction from the location 300 will be loaded, will be fetched into the CPU, into the register called instruction register or CIR. So what happened next is that you need to know what is this for. Okay. Let me, so load 1 is for load. Let me 5 is for add, 2 is for store. Okay. So all of this is fetch, decode, and all of this is execute. And before this will be decode. Okay, for step 1 and step 2, you get it? Because I only explain for step 1 and step 2. Any
Yes,
question for step 1 and step 2? It is clear? Or you are thinking?
Very confused.
Okay, so maybe I explain one more time step 1 and step 2, and then based on that, try to discuss with your group member. After that, if you still confused with the discussion, you can contact me. Okay, what is your confusion? Is it okay like that?
Okay, Doctor.
Yes.
Okay, good. Okay, because you don't know what is this, so I put it here. Okay, this opcode mean load, this opcode mean add, and this opcode mean store. Okay, so and the other three means the address. Okay, so I think that is the basis that you need for you to further discuss with your group member. So how you want to do? Do you want to do like before video, or what is the best thing to do as the proof of the discussion? Is it okay doing the videos? Is it okay?
Madam, can we just do like slide?
Okay,
Specifically slide.
slides, and then
Presentation.
you put your audio there.
Hold on, I'm thinking.
Or maybe just a report.
Can we just put the screenshot of our conversation in WhatsApp at the slide? Like you have
I
to
think
share the
Video will be
video
much
is
easier.
better, and even though it's kind of
Doing,
hard, but it's
yeah,
better.
doing a report.
I think video is better.
You can think because I want to hear your voice. I want to make it easy for you. So I just want to see
Madam.
that there is a discussion happen inside the group. Okay, so I can see the attitude of you in discussion, and also so I want to make it easy for you. If the video is takes you a lot of time, just make a simple video. I mean, you can just I don't know. I mean something. If you still like doing video, think something that easy to do. Can get me? How to
Doctor,
explain that? Yes.
I have something to ask. Based on this diagram here, so the first picture, it shows the 300, 301. All those things are address, and the 1940 is the value, right?
Okay. Wait.
Okay, so
Okay.
okay.
Can
So
you
in
repeat
the
again? Sorry.
based on the first picture, it shows like the 300, 301, 302. They are the address, and beside them is are the values, right?
300.
They are the address, and beside them it's the value, right?
You mean 300 here and this one?
Yeah, 300 and the 1940. The 1940 is the value, right?
Oh yes, this is the value.
Okay, the value. So, the 1940 is the current information, right?
Current instruction.
Okay,
Yeah.
a current instruction. Okay, so the OP code is 940. So for 940, when we send it to the memory buffer thing, the output, the accumulator will be 0003, right? That's how it goes, right?
Yeah.
Okay, okay, thank you.
Okay. Yeah. So the opcode you want, right?
Wait. Isn't
Yes.
the 940 like 1940? Isn't one the opcode and 940 the operand, right?
Okay. This one. One is the. You can see my. You can see my cursor, right?
No.
No.
Oh yeah.
It's a little bit hard to notice it. Okay, see it.
Okay. This is one. One is opcode. Let me write here. 1942. So this is the instruction, right? So the first 4 bit, still remember the most significant bit, 4 bit. So the most significant bit, one, which is 0001, 4 bit. This is the opcode. And the least significant bit here, this the least significant bit, this is the address. Okay, that one is okay.
Okay, doctor.
All right. So any more questions?
No, doctor.
Yes.
So, doctor, what's our task?
Okay. This is the task. How many fetch, decode, execute cycles? Second one, how many instructions involved and what are the instructions? And the third one, how to change the instruction so that the results is stored, ID here, is stored in location 940. So you just have to answer these 3 questions. Okay, so maybe maybe if you like to video, you can do it if you love to do that. But because this discussion is more to direct answers, like your friend said, maybe you can just write the answers. Okay. Anything that convenient to all of the groups. I just want to make sure that you convenient with the way to discuss, and then it will not take a lot of your time. I just want you to discuss and have something which is the understanding of the topics, and then maybe it is very useful for you for the in your future, in your next subjects and so on. So is it okay? It's up for you in the groups to finalize what is the best option. But for the first task before, I really want in videos because I want you to explain it. But in this second task, it depends on the group because you can explain it in videos, and or you just want to write a document, is okay. Just a very simple document then. Okay, is it clear about the task? I will create the homework task in the
Clear,
IPM.
doctor.
Okay, good.
So just like last time, one group, only one submission, right?
Yes. Okay.
And doctor, all we have to do is answer the questions, right?
Yes. Only this on this homework, I just want you to answer the questions. No need to explain.
So the
But when you discuss, you can discuss more than what I ask here. I mean that you can discuss more what is really happen inside the this basic instruction cycle. So next time during our class, when I ask you again about this, you already know what the answers. Is it okay?
Sorry, doctor. Sorry?
Yes?
I don't have a discussion group.
You can check in UKM Folio.
The group is on the UCAM folio?
Yes.
Oh, okay, thank you.
All right.
Okay, doctor.
Okay.
What is the timeline?
Or before our lecture next week.
Next week our lecture.
Yes, before our lecture.
Okay. Got it. Thank you, doctor.
Okay. So what is the time now? I have time. Okay.
About the quiz, the Kahoot quiz, doctor.
I don't think it's enough time to do that, right?
Yeah, how about our attendance? Oh.
What is the time now? Okay, I want to see.
Doctor, I
Doctor.
Already 6.
26. Okay. So I think we do Kahoot next week. Okay, before our class, we just want to test your understanding about ISA. So we do Kahoot quiz. But I just want you, I want to know your style of learning, so that I can improve my teaching, and also because I also one of the head of programs for PM for IT. So I really want to know the behavior of the students now. So I really want, if you have free times, can you please fill this form for me? Is it okay? Okay, during your free time, just 1 to 2 minutes only.
Already fill it.
Oh, that's good.
Wait,
Okay.
doctor, is it the same form?
Yes, the same from the start of the class.
No, link looks different, or am I just blind? I'll just check later.
Okay. Okay.
Doctor.
Mm-hmm.
So there are two tasks, right? From the ad and from the discussion, is it?
Yes, the discussion, and just you please fill the form for me. Okay. Is it okay? For discussion, I will create the task in the UKM folio. I have not yet created that.
Doctor, can you put the QR code up again?
Yeah.
Yes, doctor, the QR code. Okay, thank you.
Okay. So, any last question before we end our class today?